This is our lecture 3. It's all about concurrency control. Controlling concurrency access. In computer science, especially in the field of computer programming, multiprocessors, and databases, concurrency control ensures that correct results for concurrent operations are generated while getting those results as quickly as possible. So when we talk about concurrency control, we make reference to a set of control to avoid possible inconsistencies in a data when working with environments with multiple users. So in computer systems, both software and hardware, it consists of modules or components. Each component is designed to meet certain consistency rules. So when components that operate concurrently interact by messaging or by sharing access data, a certain component's consistency may be violated by another component. So the general area of concurrency control provides rules, methods, design methodologies to maintain the consistency of components operating concurrently while interacting, and the consistency and correctness of the whole system. The advantages of controlling or concurrency control is to increase the performance as well as the resource utilization of our computer. At the same time, it decreases waiting time. Concurrency control in databases. So, concurrency control in database management system, other transactional object, or the object with state access and modified by database transactions and related distributed application ensures that database transactions are performed concurrently without the concurrency violation the integrity of the respected database. So thus, concurrency control is essential component for correctness in any systems where two database transactions or more can access the same data concurrently. So a DBMS usually guarantees that only serializable transaction schedules are generated for correctness. So a DBMS can guarantee that serializable transaction schedule when the serializable isolation level is enforced, but does not always do so by default. So, and a DBMS does not always guarantee that only serializable transactions schedule are generated by default, although serializability is considered the gold standard for correctness in transaction schedule. So, a DBMS can also guarantee that no effect of committed transactions is lost and no effect of aborted transaction remains in the related database. Yeah, so there's some part of the DBMS problem later on that we discuss. So in computer science, ACID, atomicity, consistency, isolation, and durability is a set of properties that guarantee database transactions are processed reliably. Ayan. In database system, isolation is a property that defines how or when the changes made by one operation become visible to other concurrent operation. So isolation is one of the ACID property or the database property. Ayan. So atomicity requires that database modification must follow all or nothing rule. So in atomicity, if one part of the transaction fails, the entire transaction fails and the database state is left unchanged. Ayan, atomicity. Inconsistency, ensure that any transactions the database perform will take it from one consistent state to another. Ayan, consistency state that only valid data will be written to the database. Ayan. And isolation refers to the requirement that other operation cannot access data that has been modified during transaction that has not yet completed. Yan, sa isolation, as the name itself. The question of isolation occurs in case of concurrent transaction. So, multiple transaction, concurrent transaction is multiple transaction occurring at the same time. In durability, the ability of the DBMS to recover the committed transaction update against any kind of system failure. Yan, so it is the DBMS guarantee that once the user has been notified of a transaction success, the transaction will not be lost. The transaction data changes will survive system failure. So this is one of the very important traits of the DBMS. And that all integrity constraints has been satisfied, so the DBMS will need to reverse the transaction. Yan. So in isolation level, so we have serializable. Serializable is the highest isolation level. It specifies that all transactions occurs in a completely isolated fashion. Ayan. Saan na ba ako? Or in other words, if all transactions in the system had executed serially one after another. So serializable means it is very important to ensure the correctness and to prevent other issues in the DBMS like dirty reads, loss updates, as well as inconsistency read. Then we have the repeatable reads. In this isolation level, a lock-based concurrency control DBMS implementation keeps read and write lock, ayan, until the end of the transaction. So kailangan yon kasi to avoid loss of reading in between transaction, kasi possible na magkakaroon ng changes ang isang transaction sa transaction 1 bago mabasa ni transaction 2. Yan. So, in a read committed, in this isolation level, a lock-based concurrency control, DBMS implementation keeps write locks acquired on selected data until the end of the transactions. But read locks are released as soon as the select operation is performed. So, bawal pong in this read committed hanggat merong nagre-read, nag-write ng isang property sa DBMS, bawal po siya mag-edit or mag-write lang. Then in a read uncommitted, so this is the lowest isolation level. Yeah, so in this level, dirty reads are follows. Yeah, so one transaction may not yet committed changes made by another transaction. Later on, I will discuss it in the concurrency problem. Okay, concurrency problems, if locking is not available and several users access the data based concurrently, problems may occur in the transactions use the same data at the same time. It includes loss or variant updates, uncommitted dependency or known as the dirty read, inconsistent analysis or non-repeatable read, as well as the phantom reads. Loss updates. So loss updates occurs when two or more transactions select the same row and then update the row based on the value originally selected. So each transaction is unaware of other transaction. The last update overrides update made by other transaction, which results in loss of data. So example 1, the editors make a copy of same document. So each editor or two editors make an electronic copy of the same document. Each editor changes the copy independently and then save the changed copy, thereby overwriting the original document. The editor who saved the changed copy last overwrite change made by the first editor. So this problem could be avoided if the second editor could not make change until the first editor had finished. So this is example in number 2. Ayan. So in the loss update, so assuming na the value of x is 100, read x 100, so x equals to x plus 10. So mangyari dito 100 plus 10, 110. So hindi pa niya kinumit sa database or no changes in the database. So kailangan i-store pa sa database eh. So Habang hindi pa niya kinumit sa database, in the transaction 2, binasa na niya ang value ng x which is 100. Pero x, 100 minus 20, so 100 minus 20, 80. So value dito ni x is 110, dito 80. So nangyari doon, ni ni-write niya ang x which is 110 here, then ni-write dito ang x which is 80. So, nangyari, inconsistent na yung record. Dito nagkakaroon ng loss update. So, ma-overwrite ni transaction 2 here ang lahat ng changes na ginawa ni transaction 1. Ayan. Okay, so baba natin ito kasi may part na dirty read here. Okay. In uncommitted dependency or dirty read, the transaction reads a modified record that has not yet committed to the database. So, for example, an editor is making changes to an electronic document. During the changes, a second editor takes a copy of the document that includes all the changes made so far and distributes the document to the intended audience. The first editor then decides the changes made so far are wrong and remove the edits and save the document. So the distributed document contains edits that no longer exist and should be treated as if they never exist. So this problem could be avoided if one could read and change document until the first editor determined the changes were final. So gaya na nangyari dito. So ni-read niya yung value ni X, dinagdagan niya ng 10, then after that, hindi pa nako-commit ang hindi pa nakapag-save ng changes sa transaction 1, ni-read na ng transaction 2 ang value ni X at in-update pa bago ginawa ni transaction 1, in-update niya yung changes here, which is very inconsistent. Ayan, so nagkaroon ng dirty read here. Not committed yet but ni-read na kaagad. Ayan. Then we have inconsistent analysis or the non-repeatable read. The transaction rereads a data set and finds that the data have changed. Ayan. So, the transaction reread a data set and finds the data have changed. So, it happened when one transaction read two or more, more than once the data set. Ayan. Then, as the transaction goes by, nagkaroon po ng changes. Or for example, an editor reads the same document twice, but between each reading, the writer rewrites the document. When the editor reads the document for the second time, so nangyari yan na pag binalikan niya, nangyari at that time yung admin, binago niya yung kwento ng isang script, gano'n. So nagkakaroon ng changes. So doon nagkakaroon ng non-repeatability. Hindi na, as the name itself, hindi niya nauulit o hindi niya nabasa ulit yung original copy ng document na nabasa niya nung una. Yeah, so siyempre the original read was not repeatable. This problem could be avoided if the editor could read the document only after the writer has finished writing it. So in a phantom read naman, a transaction rereads a data set and finds that a new record has been added. Ayan. So, a transaction rereads a data set and finds that a new record has been added. It happened, nangyari ito halimbawa. Hindi pa tapos in a monthly sales. For example, katapusan ngayon, hindi pa naman kayo close ang store. Binasa niya yung monthly income, gross at saka net income in a particular month. Pero meron pang remaining time, for example, last hour, nagkaroon pa ng transaction. So, may bagong record na nabago. Siyempre, ay nadagdagdag. Siyempre, nababago yung total sales, total gross sales, as well as net income. Yan. Another example, an editor makes changes to a document submitted by a writer, but when changes are incorporated into the master copy of the document by the production department, they find that new unedited material has been added to the document by the author. Ayan. So, this problem could be avoided if no one could add new materials to the document until the editor and production department finish working with the original document. So, as what I said recently na ang binigay example ay monthly sales income. So, if ever na gano, you, you have to wait for the end of the month bago ka mag-print ng final report to that particular month. Then we have serializability. So in concurrency control databases, transaction processing and various transaction application, both centralized and distributed, a transaction schedule is serializable. Yeah. So only the serializable level ensures full serializability, but it's almost the most restrictive and costly in terms of performance. Some DBMS relax serializability to improve concurrency and performance using techniques like snapshot isolations or the multi-version concurrency control. Ayan. So, serializability. Saan ba? Transactions are normally executed concurrently since this is the most efficient way. So, serializability is the major correctness criterion for concurrent transaction execution. It is considered the highest level of isolation between transactions and plays an essential role in concurrency control as it's supported in all general purpose database system. So, general purpose database system and all database system, whether it's transaction processing system, payroll system, and so on. So, napakadami. Distributed serializability is the serializability of the schedule of transaction distributed system with the proliferation of internet, cloud computing, grid computing, and small portable powerful computing device. The need for effective distributed serializability techniques to ensure correctness in and among distributed applications seems to increase. In a commitment ordering is a general serializability technique that allows to effectively achieve distributed serializability across different concurrency control mechanism, also in a mixed heterogeneous environment with different mechanism. Ayan. So, this is a technique in DBMS that used to make the system like hybrid system na merong web, may desktop application, may UI and mobile application, can control concurrency access and can minimize the concurrency problem in a mixed heterogeneous environment. Yung mix, ibig sabihin, iba't ibang environment, mobile, web, ganun and so on. Does not interfere with the mechanism's operation and also guarantees automatic distributed deadlock resolution. So, unlike other distributed serializability mechanism, commitment ordering does not require the distribution of local concurrency operation. Ayan, so, hindi niya nire-require yung local precedence relation, yung mga first in, first out, gano'n. Locks as well, time stack. The fact which provide scalability and typically saves considerable overhead and delays in the commitment ordering. The only known effective general methods for distributed serializability is commitment ordering because in a commitment ordering, it is committed to perform first the transaction before allowing other transaction to perform such transaction. In serial schedule, one transaction executed completely before starting another transaction. Ayan. So, when one transaction execute, no other transaction is allowed. So, this type of execution of the transaction is known as non-interleaved execution. If you have noticed na one transaction executed completely before starting another transaction, kung mapapansin nyo, in the transaction 1, it execute all the transaction, then after that, it will be committed or saved into the database bago ma-proceed to next transaction. As well as same, then, for example, si transaction 2 nauna. So, read and write and commit. After that, saka na-perform si transaction 1. The properties of the serial schedule are always consistent, recoverable, cascadeless, and strict. Inconsistent, perform all transactions independently, all inconsistently manner. So, yan, mapapasin mo consistently manner, tuloy-tuloy lang siya. Yan, irrecoverable, suppose that a transaction has failed before commit state, it is recoverable. Ayan, so if ever na mag-fail, before commit state, recoverable ang transaction in a serial schedule. When it comes to cascadeless, means these transactions are performed after that it performed commit state. Ayan, so perform niya all the transaction followed by the commit state. Save niya in a database before proceeding to the next transaction and vice versa. So, commit means all this information has been updated in the database or permanently stored in the database. Then, the last one is the strict. Ayan. So, all these transactions strictly performed independently. Ayan. So, independently, strictly performed. So, magkakaiba sila. Then, in a non-serial schedule naman, this is a type of scheduling where operations of multiple transactions are interleaved. Ayan. So, simultaneous transaction niya, interleaved. So, this might lead to rise in concurrency problem since na nagre-read and write pa lang siya without commitment or commit transaction to start. Ayan. So, it has two types, serializable and non-serializable. Properties is not always consistent. Ayan. So, hindi siya consistent kasi hindi siya independently kasi posible na ay dito nakakasabay niya ang other transaction sa pagre-read. So, recoverable. So, mahirap i-recover pag ganito ang non-serial schedule kasi nag-read agad siya dito hindi niya muna pinatapos ang transaction 1. Cascadeless. Ayan. So, simultaneous ang performing ng transaction ni transaction 1 sa transaction 2. So, nagre-read siya dito, nagre-read ng first transactions, nag-read ulit si T1, so simultaneously. Strict, yeah, so all these transactions strictly perform independently. So, dito, hindi naman pinperform yan, kaya mahirap in non-serial schedule. So, difference between serial and non-serial schedule. Serial schedule, all transactions execute one after another. In non-serial schedule, all transactions execute simultaneously. No concurrency allowed in a serial schedule. Concurrency allowed in a non-serial schedule. Ayan. So, allowed ang concurrency here. Less resource utilization and CPU throughput. Ayan. So, dito, since na hindi siya sabay, so, mabilis ang execution niya. And you don't need to, hindi mo kailangan ng malakas na, na processing power here. So, while in the non-serial, since na transactions, kailangan ng processing speed. Less efficient. Ayan, ang serial schedule. more efficient ang non-serial schedule kasi it can allocate multiple transactions. No further types here. Ang non-serial schedule sa serializable and non-serializable type. Then we have method of serializability. Multi-version concurrency control keeps the old values of the data item when that item is updated. Ayan. So, ayan. So, na multi-version concurrency control. So, once nagkakaroon kayo ng update, i-keep niya yung old version ng old values na once na nag-update ka. So, the problem with this multi-version, mabilis lumakas ang kailangan ng more processing power tsaka kailangan ng mas malaking storage. Ayan. Kasi, para kang ini-store mo, tinago mo in historical data yung value ng old value ng isang item. Timestamps are unique identifier for each transaction are generated by the system. Yan siya, DBMS. So, unique identifier. So, to identify the timestamp as well as timestamp as the name itself, kasama na dito ma-identify yung date and time na when the transaction happened. Ayan. Transaction can be ordered according to their timestamp to ensure serializability. So, according to their timestamp, so, kakaroon dito ng first come, first serve, gano'n, to ensure that serializability, maging serializable, parang magiging, yung, tag dito, yung pagkasunod-sunod sa transaction. Protocols that it follows by every transaction will ensure serializability of all schedule in which the transaction participate. They may use locking techniques of data items to prevent multiple transactions from accessing items concurrently. Ayan, so this is some technique of the DBMS, lalo na kung meron siyang multiple admin na nag-e-edit o multiple users na nag-change nag-update ng changes sa isang record. So, pwedeng i-apply itong locking technique. Ayan, so in the DBMS, properties of the pessimistic concurrency control. Ayan. Optimistic, kung merong optimistic, yung kanya control. Ang pessimistic kasi it happen when there is a non-serial schedule na simultaneous transactions of simultaneous performing of transactions kaya nagkakaroon ng pessimistic concurrency control kasi mahirap i-manage pag ganon. Check before a database operation is executed by locking data items before they are read and write or checking timestamp. Ayan, so you have to use database operation. So you have to lock that data before reading and writing in another transactions. Or as well as you have to check the timestamp if one transactions happen. So, siyempre, unahin mo nang tapusin yung transaction na before the other. Use the timestamp. Yan. So, makikita yan. Locking techniques for concurrency control. So, the concept of locking data items is one of the main techniques used for controlling the concurrent execution of transactions. So, a lock is a variable associated with the data item in the database. Generally, there is a lock for each data item in the database. Ayan, so, depende sa programming language, sa BB, sa ASP.NET, may mga properties once na nag-perform ka ng record set manipulation or nag-select ka ng record, select all from table 1, ganon. Add open optimistic, add lock optimistic, mga ganon. So, may mga properties or code na kasama ang mga ADO.NET. So, depende sa programming language na pwede nyong gamitin na para sa behavior ng inyong record set. Kung pessimistic, add lock pessimistic lang ba siya, na pwede kang mag mag mag-read pero hindi ka pwede mag-update ng item and so on. So a lock describes the status of the data item with respect to the possible operation that can be applied to that item. It is used for synchronizing the access among current transaction to the database item. A transaction locks an object before using it. Yan. When an object is locked by another transaction, the requesting transaction must wait. Ayan. So, pag nagkaroon ng locking, ha, so, wait na, no? Kasi, depende na rin sa mga database administrator, sa mga programmer na how you deal with that concurrency control. Kasi, once na nagkakaroon ng locking technique, less problem. Kasi maraming problema talaga pag hindi mo ma-manage ang concurrency problem. So, types of lock. So, binary locks have two possible states. Lock and unlock. Kaya, so pwedeng mong lock o may unlock sa maybe other programming language. Pwedeng ang value niya 1 or 0. Ganon. Multiple mode locks allow concurrent access to the same item by several transactions. 3 possible state. Read lock or shared lock. Other transactions are allowed to read the item. Write lock or exclusive lock. A single transaction to hold the lock on the item and unlock. Yan. Lock are held in a lock table. Upgrade lock, read lock to write lock. Downgrade lock, write lock to read lock. Ayan, so these are different types of locking. Okay, so any question regarding this concurrency control access? So that's all.